Hi and welcome to the Groove Monkee series on compression. In this video we're going to have a look at a bit of an introduction to dynamics, what dynamics are, and the difference between loudness and level, because it's quite an important distinction to make when using compression. Then we're going to look at the way volume changes over time, or amplitude envelopes. And then we'll move on to what a compressor is and how it works, and then we'll look at some examples of compressing drum sounds. So to start with, the main difference between level and loudness is to do with the way our ears work, and also the way speakers reproduce sounds. But the long and the short of it is, our ears are more sensitive to some frequencies than others. In particular, we're most sensitive to the frequencies in the 1 kHz to 5 kHz range, and around 4 kHz we're particularly sensitive. Now if I just play some notes on this operator synth here, just a basic sine wave, so we're only listening to the one frequency and not getting mixed up with any other harmonics. So if I go up an octave, you can hear that sounds slightly louder, but if you look at the actual level on the spectral analyzer, it's minus 12 dB, and it comes to this position on the mixer. So going back, they're exactly the same level. Now if we go up a few octaves, you can see once it gets to 1 kHz it sounds louder again. And then when we get up to 4, it's really quite irritating and shrill and piercing. And that's because, as I said, our ears are really sensitive to that sort of frequency range up here. So even though they sound louder to us, the actual level on the meter here is exactly the same. And then if we go in the other direction, especially when you get down to the really low frequencies here in the sub-bass region, that's 32 Hz, you can barely hear that at all. And in fact, you're only likely to really hear it if you've got a subwoofer or speakers that reproduce low end really well, and even then you're more likely to feel it than hear it so much. So that's really an example of how all these different frequencies can sound louder to us, so that's the loudness, but the actual level is exactly the same. So once you put those sounds through a compressor, as far as the compressor is concerned, they're all exactly the same level. They don't change their loudness according to the pitch, because that's something that our ears do. A compressor doesn't make that distinction. So it's really important to understand that once you start using compressors. And to look at an example with drums, here we've got this 808 kit here. Now I'm using an electronic kit just purely because it's a lot easier to see for these examples, but a kick drum or a toms will have a lot of this low frequency content as well. But if I play the kick drum here, you can see it's got a very, very strong peak here at 48.5 to 49 Hz, and that goes up to all the way up to minus 12 as well. Now this sounds a little bit brighter than a sine wave would at that frequency, and that's just because there's a few other harmonics in this sound that give it that bit of clarity. But in terms of how it would affect a compressor, that frequency here is going to be the one that the compressor responds to first of all. Another really important thing to understand when looking at dynamics is the way the volume of a sound changes over time. Sometimes this is called amplitude envelopes or volume envelopes, particularly when looking at a synthesizer where you can physically manipulate these parameters as part of the way you create that sound. So, for example, on this Ableton operator synth here, we have the attack, decay, sustain and release, and sometimes you'll hear them called ADSR envelopes. And that just means that you can control how that sound changes. So if I maybe play a C3 again, the attack refers to the amount of time it takes to go from the quietest to the loudest sound. You can see if we turn it up here, so that's the attack setting there, it starts to sound like it's fading in. Now in the case of drums, usually when we're talking attack, we're talking a very short space of time, so we're not really looking at these kind of fade in sounds, we're more looking at very quick attacks. And in this particular example, it just more or less affects how clicky it will sound. So as you turn it up a little bit, it starts to sound a bit softer. Now, attack and release are the main two time controls you'll have on a compressor, and we'll look at them in the next video. But in terms of what we're actually affecting here, they're the two controls that will have the impact. So the attack, amount of time it takes to get from the quietest to the loudest, and then release the time it takes to get back to 0. So if you set a long release time, when you let go of the key, you can hear it's got that long fade out there. Then in addition to that, we have the decay, which is how long it takes to go from that loudest level down to the sustain level. And the sustain level is just how loud this stage here is that it stays at. Now if we compare this to an actual snare drum waveform that we've got here, you can see right at the start the attack phase is actually very quick. It goes from 0 up to the loudest point very, very fast. And then the decay phase is actually quite quick as well, but not quite as quick as the attack phase. And then we've got this much longer phase here, which I suppose is like the sustain level. And then the release as it goes back to 0. So most of the sound that you hear at the end is just that kind of reverberating sound, and it's certainly not the loudest part of the sound by any stretch. As we get into compressing, we'll see how we can bring that volume up. And that's effectively what we're doing in compression, is we're reducing the amount of dynamic range. And that means the difference between the loudest and quietest part of the sound. So really we're just wanting to compress it or squash it down so that these louder parts are not as far away from these quieter parts, and then we can turn the overall level up and hear all of it a lot better. So if we were to try and create that sound on here, then you'd be probably looking at something like this. So that's really kind of a way of trying to understand how the sound changes over time. And when we use a compressor, we're kind of doing a similar thing. We're just doing it in a different way. And we'll see that as we get onto using the compressor.